All right, so what we're going to be doing today.
Wait, is it recording now?
Yep, now it's recording. Everybody say hi.
Hi.
And we have one person hollering waffles. Okay. So what we're going to be doing today is we're just going to do a little bit of a review over these ideas. Okay. We do have new material today. Put the book away. We do have new material for today, but I use new with air quotes simply because you've all done it before. You might have even done it in Algebra 1. I know you didn't in Algebra 2. Okay? So hopefully today is not 100% new to anybody. We're just going to be upping the level of difficulty a little bit. But I need to make sure that you guys ask questions when you have them. You are not having a quiz over this today. You are going to have a quiz next class over both days. And this is a very, very short unit. Okay? This unit is made up of 3 things. Domain of functions. Done. Composition of functions. Today. Inverse of functions. Next class. That's it.
What was last class?
Last class, yeah. Domain. This stuff. Okay? So when we do these problems, you want to make sure that you understand when we do and do not have restrictions. Now, we started off, or you started off in Algebra 2, actually, talking about fractions. When we're talking about fractions, what are the restrictions that come from those? The denominator does equal 0? It cannot. The denominator cannot equal 0. Okay. Then we moved up to roots, which is something you also did in Algebra 2. We call those radicals. But not just any type of radical. Thank you. Radicals with even roots. What's true about a radical with an even root? What's true about those guys? They have to be greater than or equal to 0. That color. So these guys have to be greater than or equal to 0. We did pick up one new-ish thing, and that was logs. And that's the fact the stuff after logs has to be what? Greater than 0. If it is not one of those, it's going to be all real numbers. Easy peasy lemon squeezy? Yeah, no, nah, neat. All right, so if I'm looking at number 1, does number 1 have a fraction? I was going to say, really? It has a fraction? I know. Number 1 does not have a fraction. Does it have a radical? Nope. Does it have a log? No. Oh my gosh. That means all real numbers. No. Sometimes you guys miss the obvious stuff. You're looking so hard for, yep, it doesn't matter what class you're in, you're looking so hard for the very specific hard stuff that when I throw an easy one at you, you freak out. All right, if you're writing this in interval notation, negative infinity to positive infinity, both with parentheses. Now, what do you have on number 2?
Fraction.
It's a fraction. Yay! Just in case you couldn't tell by looking at it. And for fractions, what has to be true? The denominator cannot equal 0. What makes that 0?
0.
I know, trick question. 0 makes that 0. So, in set notation, we always have to say what x can be before we state what it can't be. So it's an element of the reals, but not 0. If you were to do this in interval notation, it would go from negative infinity to 0, both with parentheses, union 0 to infinity. I do not care. I don't even care if you go from one question to another, mix and matching. But please do not combine interval and set notation in the same problem.
Wait, so for all the fractions, the denominator can't equal 0?
Yeah, what happens when you divide by 0?
You get 0.
You get a black hole. Your calculator breaks. Don't do it.
You can ask Siri. What's 0 divided by 0?
Oh, it's so funny. She tells you and you've done it.
Yeah.
All right, so for number 3, come on. Number 3, what do we have?
A radical.
A radical, it's just the rad, with an even root. Because what root is technically there? 2. So what has to be true about my radical?
Greater than 0.
Can it be equal to 0?
Yes.
Yes, so greater than or equal to. So we factor this puppy. It's okay if you just solve it and say add 4, but you need to make sure that you're very careful, because what answers do you get from this? Plus and a minus 2. If you just take a square root, remember, if you start with a square and you take a square root, you have to have plus or minus. Okay? So this is where we go into our lovely little plotting this out, take some examples. Now, I know, open or closed? Closed. And if you can't tell by looking at the problem, for example, I can tell that this graph opens up because it's a positive x squared, and so the positive values will be on the outside. If you cannot do that, plug in values and to see if it's positive. If it's positive, shade there. If not, don't. So that means my final answer for this, either in set notation, x is less than or equal to negative 2, x is greater than or equal to 2, or interval notation, negative infinity to negative 2, this time with a bracket, union 2 to infinity and beyond. What up?
What if it's odd?
What if it's odd? If it's odd, you don't have a restriction from it.
Wait, what would make it odd if it was like
If this was odd.
if it was like a cube root?
Cube root, 5th root, 7th root, any of those. No restrictions. The reason why square roots, in order to be a function, we only look at the positive values. But a cube root, a 5th root, those are one-to-one functions. Those pass the vertical line test.
So if it was like an odd root, would you still solve it like that?
No, if it was an odd root, you would simply state like what we have right here. All real numbers. We only get the restriction from radicals if your root is even. If not, you go to the all reals. Okay. Now, number 7, we've got a couple of things going on here. First thing I see is a fraction.
Say number 7.
I saw the 7 on the top, so yes, I did. Number 4. I see math problems and other problems. All right, so number 4, we have a fraction. What's true about the fraction?
There's a numerator and a denominator.
Okay, restrictions from the fraction.
Can't equal 0.
Cannot equal 0. But I also see a root. What is true from the root? Has to be greater than or equal to 0. So if we put those two together, what is my restriction? It has to be greater than. So this whole thing has to be greater than 0. How do I start solving this? There you go. Take out the 4x squared. And we are left with what?
2 plus x.
2 plus x. So from here I get a 0. From here I get a negative 2. Be really careful with these guys, especially since that's a cube. It's going to have a different appearance than a quadratic. So I have negative 2 is the smaller number, 0 is the bigger. If I try plugging in values, let's say I were to plug in a negative 1. What is negative 1 squared? Positive 1. So this whole thing will be positive. What's 2 plus negative 1? 1. Positive times a positive is a positive. That works. If I plug in a positive 1, that's going to be a positive 4. That's going to be a positive 3. Positive times a positive is a positive. If I were to plug in a negative 3, this would be positive, this would be negative. That does not work. So you've got some weird stuff going on here. What kind of circles do I have? Open or closed? Open, because it is greater than. This is part of my answer. That is not. And this is part of my answer. So the way that we would write this, if you were to do interval notation, you would say from negative 2, parenthesis, to 0 with the parenthesis, union 0 to infinity. Or if you were going to do set notation, It's the set of x such that x is greater than negative 2, but x can't be 0.
Why not say x is less than 0?
I'm sorry?
Why not say x is less than 0?
Because less than 0 is going to continue on over here, which isn't part of the answer. Okay, anybody else? Questions? Near? Alrighty, logs. Log. What's the restriction on logs? Greater than 0 for this stuff. So that means, pure and simple, x has to be greater than negative 7/3. Watch your signs. So there it is in set notation. What do you get from this one? Okay, yeah, you're going to have plus or minus 1, but what is the restriction? Has to be greater than 0 again. And you're right, from this you get a positive 1 and a negative 1. So again, go back to your number line. I happen to know it opens up, so I happen to know it's going to go out. If you can't tell by looking at the equation, plug in values. There's nothing wrong with that. So I can either say negative infinity to negative 1, union 1 to infinity, or the set of x's such that x is less than negative 1, x is greater than positive 1. Technically, that's an or. All right, go eat and come back. So let's take a look at the homework. Give you guys a chance to check your answers on that. Now, I like to write mine in set notation. That's just kind of where I go with it. You're welcome to write that in interval notation if you choose. I just didn't feel like doing every answer twice. Let me zoom in just a little bit. There we go. I tried to give you a little bit of explanation, such as on number 7, has to be both greater than or equal to 0 and not equal to 0, which is why I chose greater than.
So you always have to solve, like set the top and the bottom equal to 0.
Not always. For example, number 12, that's just a polynomial that has no restrictions. And if you look at number 7, 7 does have a top and a bottom, but it's not in a log, so the only restrictions come from the denominator. Okay, going back to what we had before. Fractions, you only care about the denominators. If I put a fraction in a log, then yes, you're going to have to worry about more. Okay? All right, see the last of those. Uh-huh.
Can you explain?
Absolutely. First off, you do see a fraction, correct?
Yes.
Now, you would normally think in a fraction the denominator can't be 0. And you would say from the radical, you would think normally greater than or equal to 0.
Yeah.
Problem is that is an odd root there. So the radical rules don't apply. The only rule that applies on that problem is the fact that the denominator cannot equal 0. Okay? So again, we only have these rules if the radical is an even power. If it's not an even power, then we don't have any restriction that comes from that. Yes, ma'am. Absolutely. Is number 12 a fraction? Nope. Does it have a radical in it? Does it have a log in it? So it has no restrictions. It's one of those things where you guys, and I even did this the first time too, it's like, oh my gosh, I'm going to have to try to factor by grouping, but it doesn't factor by grouping, oh my gosh. But then you got to think, wait, what am I doing? You're just stating the domain. You can put any number you want in there, any real number.
Can we go for number 3?
Okay, number 3, the reason why we have no restrictions is because if I look at that, that's x squared plus 9. There is no real solution to that. If I were to solve that, I would have plus or minus 3i. That's not a real number. So there's no number I can put into that denominator that would get me a 0 coming out. That's why there are no restrictions.
But it says no solution.
There's no solution to that equation. Do-do-do-do. Number 11 didn't state a root, so that root was the second root. That's an even root. So we have to make sure that's greater than 0, greater than or equal to. All right? Factor. If you don't factor, please remember that if you start off with a variable squared, you're always going to have plus or minus a square root. Then, when we do this, the easiest way to do these problems is wrong. This problem is wrong. Okay? The easiest way to do these problems is, I like to picture the graph. The graph of this guy is a negative x squared. So it opens down. So it's the part that's in the middle. Thank you for pointing that out. So this should be x's such that, and please make sure you will lose points if you don't do this, small, medium, large, and they're always less than symbols. Thank you for pointing that out. I'm an epic failure. I'm so sorry. It can be equal to 0, because you can take the square root of 0. Square root of 0 is just 0. Can you get one of you guys to shut the door for me, please? Leave it open a smidge so that we don't have to yell at Kurt when he gets back.
The guy in the bachelor that decided to marry the other girl, did the other girl take him back?
I don't know. We will find out tonight. But for now, that came out of nowhere.
Sorry. You were like, you said like, oh, like, I'm a failure or whatever, and I was like, oh, the guy that made the mistake, and then I was like, how could she take him back?
Train of thought. So interesting sometimes. All right, so now let's look at the other side, the rest of our answers. And again, I tried to point out for you guys that if it is an odd root, you have no restrictions. You have no restrictions today. Sorry, that's an old AFES commercial. AFN. Military TV. You know what I'm talking about? Do you even know the commercial I'm talking about? Oh, no. You can't mail explosives. You can't mail explosives today or any day. Okay, yeah.
What was that?
It was a TV commercial when I lived in Germany.
Oh, yeah.
It was an American commercial.
Oh, yeah, those channels.
They were very special. High level.
There's some nice commercials, actually.
Yeah.
Why would they tell people they couldn't?
Because you can't mail explosives.
Well, why would somebody try to?
Because
people do that all the time. I'm going to mail you fireworks. That's the word I was looking for. The Unabomber? Yeah. He was in trouble for not just mailing explosives. There were other things involved with that. Wow! All right, refocusing here. Sparkle! Squirrel! Squirrel!
Everything
Everything has been recorded. Yes, isn't it wonderful? Okay, hush up. All right, let's see here. So we looked at through 17, so let's scooch it down a bit. All right, there you go. And that's actually a little off. Yes. I will be editing this, maybe not.
Isn't the internet great?
Yay!
I'd edit it.
I really don't care. Whatever. Yes, ma'am. You set the top and bottom equal to 0 on problems like number 25 and 26, where they're inside a log. Because it's not just that the problem with that is the entire fraction has to be greater than 0, whereas a fraction restriction is just the denominator cannot equal 0. So we have to pick the most strict requirements. Okay? Yes?
For number 24, can you rewrite the answers like parentheses 0, 1 parentheses? Or...
Oh, you're talking about interval notation? Yes, that's perfectly fine. This one can be written as a parenthesis 0, comma, 1 parenthesis. Yes. Yeah. What's your question?
For number 22, right?
Okay.
Can I keep it 0? Like, say x is greater
I'm sorry.
than 0 and less than 2?
Where are you getting the 0 from?
You take a 3 out.
We're looking at 21?
22.
Okay, 22. When you take the 3 out, when you factor out that 3, that's going to be 2 minus x, right?
Yeah.
There's no variable with that.
Don't we just be 0?
No, there's no variable. You can't have a 0 unless you have a variable.
Okay.
Okay? 8. It's good. So. Your nails taste good. You know you can get worms that way.
You get what?
You
Worms.
I can get worms from biting my nails.
Yep.
You're talking about me. I was like, I have an obsessive habit of doing that.
Then I'd probably stop. I would kind of hold back if I were you. All right. So we are moving on today, and like I said, we've done domain. We're going to keep doing domain. That's not going away. But what we're talking about today is called composition of functions. You remember fog and goth? Did teachers ever say it that way? Well, some teachers do because that's what it kind of looks like when you're writing it down this way. It kind of looks like fog. F of G. G of F. Goth. The thing that is really, really important here is that you do not confuse an open circle with a closed circle. Those are completely different things. I can't keep missing class like this. Okay, those are completely different things, so do not mistake them. Basically, composition of functions, it's a function machine is sometimes what they talk about it as. So it says, okay, here I have one function, and into that I'm going to put something else. It's like a soda machine. This machine is holding all of these different drinks. I put some money in, an answer comes out. Then maybe you're going to use that soda as bribing somebody else to take you home. So you take that soda, you give it to somebody else, and you get driven home. That's a composition of functions. We're doing that here, and this is actually something that you should have spent quite a bit of time of in Algebra 2. I understand that it might have been a little while, you might have forgotten, but technically speaking, when you learn something in school, you are supposed to remember it. I know, crazy expectations. Okay, so we're going to do a little bit of a review here. Now, please understand that none of this material I'm showing you today is different. No new rules. The only thing that's different from what you might have seen in the past is the level of difficulty. I'm kicking it up a notch. This first problem is an example of something you sure as well could have seen last year. Write that problem down for me, please. We're going to be doing two things with this. We're actually going to be finding the composition, and then to build off what we did last class, we're going to be doing the domain restrictions. Please also understand, before we even get going here, f of g and g of f are not necessarily the same thing. They're very rarely going to be the same thing. Usually the only time that happens is if they are inverses, and that's next lesson. Okay. F to the negative 1, yes. All right, now, the way I do this, one of the biggest issues that I see is often kind of magnified by this first example. For this first example, I'm starting with f. You can write this a couple of ways. You can write it this way, or you could say, I'm going to start with f, and into f is going to go the function for g. I'm going to substitute that in. Where people have issues is the fact that in f, there are multiple variables. So what I like to do is I like to put kind of like what I call buckets in there. I'm going to place each of my variables with a bucket. What's going to go into that bucket? X minus 4. That is the whole concept of composition. Do we get a stop there? No. What do we have to do? All I'm hearing is like... Distribute the 2. Can I distribute this 2? And say x squared minus 16? Only if you're killing kitties. Stop it. Do not kill kitties. What does squared mean? Times it by itself. Foil! I am going to be very, very hard on you, and you will get very few points partial credit if you tell me that x minus 4 squared is x squared minus 16. You will get no pity from me. Die, problem, die. All right? What does x minus 4 squared work out to be? That's quite a bit different than x squared minus 16. Now when I distribute my 2 over here, what are you going to have? Thank you. Making sure that you're distributing that to both. There's a big difference. This is multiplication of a constant. This is squaring an expression. Okay? Squaring is doing multiplication many, many times. All right. Now we get to combine like terms. So I'm going to say my f of g of x, x just means that there's still a variable left in it here, is going to be what? What does this simplify to? Beautiful. So that, my friends, is the composition function, the composition of those functions. Now, if I want to talk about the domain of this, which I do, what are my restrictions for this? None. So what's my domain? All reals. So either from negative infinity, comma infinity in parentheses, or in set notation, whichever one you like. Now, I've done that first one. I've done fog, f of g. You can do guff. So you know they're not always going to be this straightforward. A lot of times we have to use that thing that's located between your ears. And I'm not talking about the wax. You like that? Not strange at all. All right, can I pull up the answer?
Sure.
All righty. How do we do? It's so much easier to do it this way. If I ask you to find f of g and you're going, hey, wait, wouldn't it be easier to do it the other way? Maybe it is, but that's not what I asked you to do. The answers here are clearly not the same thing. Now, this is the main concept for today. All we're going to do is we're going to work up the ladder of difficulty. Okay? So let's try the next function that we're going to attack. I think I've got 4 planned for us and then some classwork. So go ahead and write down the second problem, the second set of givens. And I can pretty well say I think the fractions are going to be your biggest struggle. It means you're going to have to pay very close attention to not make mistakes. All right, I want you guys to actually do for me, please, f of g. Go ahead and work out f of g.
We're gonna have to do problems that require us to have like 3 functions.
No, we're not going to do combination of multiple functions. That's not the focus here. The focus is more talking about what happens with the domain as we combine these guys.
Okay.
Remember, you're not just doing the composition, you are also finding the restrictions for the domain. Yay now. All right. I'm hoping this was okay. Yes? All right, let's see what it looks like. Here's my answer. Substitution part of this should have been pretty nice. Nothing crazy. The one thing I was really worried about, for your restrictions, did you get plus or minus root 2? You want to make sure if you're starting off with an x squared, you always have a plus or minus. Yes, ma'am?
In your domain, you just wrote plus or minus.
Oh, thank you very much. Stop judging me. That's my job.
To judge us.
Yes.
Yeah. You're good at it.
Like the look on your face when you said that. You're good at that. Grr. All right, now, still using the same functions, but yes, sometimes certain directions will be more difficult than others, more complicated. It's just because of what the functions are. So when I'm talking about g of f, which one goes first? Which one do I start with?
G.
G. And G is something squared minus 1. What goes into that? X over x minus 1. All right, ladies and gentlemen, be very, very careful here. When you square x over x minus 1, what do you get?
X squared over x minus 1 squared.
Okay, but what is that?
X squared minus 2.
X squared minus 2x plus 1. When there is no plus or minus sign, yes, you can distribute your exponents. When there is a plus or minus sign, you got to realize that that is going to be FOILed. Now, we get a little bit of a hiccup here. It's the fact that we cannot leave our answer like this. What do I have to do? Kurt?
Could you move 1 to the other side so that cannot be 1?
No, because we're not talking about the restriction on this. We want to actually find the simplified version.
Oh, we factor first. Okay, so we're going to factor at the bottom.
No. What do I need in order to combine these? Common denominator.
Should we factor to make it easier?
Well, if we look at this, I would say yes if I thought something was going to cancel out or if I had a complicated thing to worry about. But I'm not going to really factor this here because the common denominator is just going to be that stuff. And please remember, guys, I'm kind of struggling as to why people are having a hard time remembering this. Any integer is a number over 1, and to find a common denominator, we times the top and bottom by whatever that would be. So that means I'm now going to have the common denominator of x squared minus 2x plus 1. In the numerator, I have that first x squared. But be careful. Distribute a negative. So what is this going to give you? Negative x squared plus 2x minus 1. You have to distribute that negative to each of those pieces. Be very careful. Those little things are not difficult, but it's so easy to make a mistake. So that means I'm going to have these two cancel each other out. I will have 2x minus 1 over x squared, minus 2x plus 1. That is my g of f. Now my domain restrictions. This is a fraction. What can we not have in the denominator? A 0. So it's going to be all real numbers. What makes that denominator 0? Hint, we already had it factored above. A 1. Kurt.
Does it not really matter if, because like, so that could also be read as like 1 minus 1. And so what you could do is like x squared minus x squared, and that would cancel out. And then you would have nothing minus a negative 2x.
That's fine, but nobody really does it that way because you're actually making life more complicated by doing it that way.
Okay.
Say, I'm going to split up this fraction into this piece and that piece, and you don't really need to do that because simply if you add across the top, what you're left with is what you're left with. Okay? All right. Now here is where you guys get really, really happy. BT dubs, that's sarcasm. Go ahead and write the problem down. And it's not the fact that the composition is difficult. It's the simplification. It's the algebra, not the trig stuff. Yes, sir. Stop it. No sneezes. Try. I'm just kidding. You know you got Kleenexes if you need them. Huh? I don't care. I would have said it anyway. Wait, I did say it.
Good point.
Have I acted any differently than usual today? What do you think?
Well, you reciprocated the fact that you just said, don't sneeze, by saying, have some Kleenexes.
I would have said, well, he sounded a little boogery, so wanted to make sure he knew that he had that option. You want your parents to experience your math class. And we have all these requests for conferences. My child does not need to have a crazy person for their teacher. All right, so f of g. What am I starting with here? Really not a trick question. What are you starting with? Yes, it's the first letter written, F. Okay, so I'm going to start with F, and in the place of each one of my variables, I'm going to put a bucket, aka parentheses. And what's going to go in that bucket?
G.
G. G, I think you're right. That wasn't really funny. I tried. And we already start to see where the issue comes from. So again, just because I've seen a lot of people struggling for some reason with this, to multiply a whole number times a fraction, top times top, bottom times bottom. Not sure what's going wrong today. With maybe it's just that first class. So now I have x minus 2 over x minus 1 divided by Crazy Town. What is this going to be? Thank you for distributing. And then there's a big minus 1. Look at all the fractions in a fraction. There are many ways that you can solve this problem. I notice this. What did I notice? Not necessarily. They are the same. The reason why they don't cancel is because there's not one with this.
Right.
Okay? But
You can't make it.
I can make it cancel. What we can do here is if we have a fraction within a fraction, if you look at all of the denominators in your fraction, and you say, all right, what would the common denominator be? What would the common denominator be here? X minus 1. So I'm going to take this whole kit and caboodle, and I'm going to times all of the top by x minus 1, all of the bottom times x minus 1. Because what is this equal to? Something over itself? 1. So I'm not really changing it. I'm just not changing its size. I'm changing its appearance. Now when I distribute this, distributing it in here, what's going to happen? Those are going to cancel out, and I'm going to be left with x minus 2 for my numerator. But be careful. There is this plus or minus sign. That means we have to distribute. We're going to distribute that to this first. What is it going to give me when I distribute it over here? 2x minus 4. When I distribute it here, what am I going to have? Negative x plus 1. Yep, watch those signs. They're not difficult, but they're so easy to mess up. And then we just combine like terms. So I will have x minus 2 over what? X minus 3. Our restrictions come from the very end of this. So what do I say? X can't be 3. So x is all reals, x, such that x is an element of the reals. Tell me what it can be before you tell me what it can't be. Maya.
Why couldn't you turn that 1 into a fraction and then subtract?
You could have, but this kind of takes that and reduces the number of steps by 1 or 2. It's perfectly fine if you did that. And what she's talking about is she's looking at the denominator right here, and she says, gotcha. And that's part of the reason why I always try to look for the fewest mistakes. I say work smarter, not harder, because the more steps you do, the more options for a mistake you throw in there. All right, so let's see if you guys can handle the g of f on your own. Very, very similar, different positions. Okay, yeah, sure.
Yeah.
There you go. You're so difficult, Kurt. Hi, Katie. Matt, did you do that already?
Yeah.
Whole thing?
Yeah.
Speedy Gonzalez. You okay, Annabelle? What you stuck on? What you stuck on?
Oh, it's okay. You have to stay.
Check your answer with your neighbor when you think you got it. Catch each other's mistakes. Hopefully there aren't any. Very squeaky chair today.
I think so, but
Oh, the level of confidence. Yeah, I think so. I didn't say it quite so high pitched though. All right, here's my answer. Take a look at that, please. Wow, you did it? Yay!
I'm not going to look at each other.
Okay, honestly, it's kind of nice not having Joe here so I can do this.
It's what?
It's nice not having Joe here so I can do this.
Well,
And before I was like smacking the things, he'd be like, thanks.
Ah, so special. Rebecca and her hidden violent tendencies. Whatever. Don't leave a mark. All right, questions on this problem. Cameron, stop playing with it. No questions? Got it!
Soft kitty.
Yes, that's my soft kitty shirt. Leave it alone. All right, we're going to try one more problem. One more problem, then I'm going to give you guys some classwork. Okay, we are doing both f of g and g of f for this problem. Yes, sir.
after this problem, I write them after recording.
We'll see.
It's actually really cool.
We'll see.
Does it sound like for homework?
Before classwork. I just want to make sure you guys see a little bit of everything.
Are there ever going to be like logs in this?
Yeah. It's just you plug it inside of it. Well, whatever one is, you plug it inside the other. Just don't worry about it. It's going to be a lot easier when you see it. You're overthinking. Shh. Don't overthink it. I ask two things. If it can be simplified, simplify it. If there is a fraction involved, always condense it to just one fraction. Not one fraction and stuff, but one fraction.
So for this problem, is like the domain the answer, or is it?
No, it's a two-step answer. The answer is what you get from doing the composition,
Okay.
plus that function's restrictions. Okay? I'm passing out your classwork so that you finish this. You can go ahead and get started. You may not have enough room on this to do all of your work. If that's the case, just do your work on a separate sheet.
Guy.
Come on, wake up.
Heard it when she said, what, hold on.
Well, no, I haven't.
Okay, what? Oh, I apologize.
Come on, ladies and gentlemen, let's be working.
Great.
See a lot of people writing, but I don't know if it's on this or the classwork. So raise your hand if you were done with this. So we're about 2/3. All right, I'll give you a little bit longer. All right, I'm going to pull up the answers. All right, just hang on a second, guys. Please process what's up there. And I'm going to point out a couple of things to you. First off, I said that I'm going to ask you to do two things. If it can be simplified, simplify it. If it's written as a fraction, make sure it's all one fraction. So you need to get this together as a common denominator, and this is what you get. But that does not simplify further. It is a root problem, and it is a square root. So square roots technically have to be greater than 0. But if we look at what we have in here, x squared plus 1, x squared is always positive. Plus 1 is always going to be positive. Over x squared, positive. That is never going to be negative. So the only restriction that I get from this comes from the fact that there is a fraction and the denominator itself cannot be 0. So that's why I have x can't be 0. Yes, ma'am?
Can't you just simplify it?
No! The reason why, let's think about it this way. Give me a number. Give me a number. 10. What's 10 squared?
100.
Plus 1?
101.
Divided by 100, is that 1? No. I can pick any number. Let's say 3 squared plus 1 over 3 squared. You cannot just go like that.
No.
Oh.
I meant like the root of 1 plus, or x squared plus 1.
Again, we can't do that. It's the same thing as foiling. Because there's a plus sign in there, we'd have to be able to write it as a perfect square before we could take a square root of it. So basically, if you have a plus or minus sign in there, you can't. Yes, ma'am?
I'm confused as to why x is not equal to 0 if it's never going to be negative.
It's never going to be negative, but it is a fraction. And remember, fractions can't divide by 0. 0 is not negative. So even if I plugged 0 in here,
But because it's a radical, it has to be greater than or equal to 0.
greater than or equal to, but there's a fraction involved. Remember, we're combining restrictions here. We're saying that this full thing has to be greater than or equal to 0, but it's a fraction. The denominator cannot be equal to 0 itself. So we're laying layer upon layer of restrictions here. We do not get a restriction from the fact that it is a radical because it's never going to be negative. But if I look at just the fraction, if I put 0 in here, I would have 1 divided by 0, which is undefined.
Right.
That means it's not a real number.
Right, so why can't you say x is greater than 0?
Because I could put a negative number in here. Negative 2 squared is
2. Or 4.
4. 4 plus 1 is,
5.
and negative 2 squared is 4. So that's still a positive number. So you can have negative values here.
Right, so but that would be greater than 0.
No. You're talking about the final solution for x. If I say x is a negative number, x is not greater than 0. Do you see where I'm going with that? There's a difference between what the answer you get out is and what the number you're putting in. All right. So, yes, ma'am.
Because when you do square root of fraction, can't you square root the top and bottom?
Had this just been that, yes, I could have said 1 over x. But because that plus 1 is there, it's like if I asked you to take the square root of 3 squared plus 1. That is not 4. 3 squared is 9 plus 1 is 10. The square root of 10 is not the square root of 3 squared plus the square root of 1. Okay? It's the same thing as that distribution with the square, because remember, a root is still a 1/2 power. So all the rules apply.
Oh no, she's saying like for the second one you have in blue, right? The square root of x squared plus 1 over x squared. Isn't that also read as like the square root applies to the numerator and the denominator?
No, when I plug this in, this is where the square root is. It is not in the numerator. The square root is only in the denominator.
I know, but look.
No, we're going to move on because you're confusing other people in the classroom right now. Okay, so I will work with you on it one-on-one if you need, but you guys are overthinking it, and it's making it more difficult for other people to understand. So, you have two things. First off, you have classwork, which I have just given to you, and your homework is textbook work. So, I am going to expect you for your classwork, there are 6 problems. You got to do 5 of them. Okay? Because you've got about 30 minutes. You can do 5 in 30 minutes. I'm sorry? That's your classwork.
Right. So we have to do
5 of those. For each problem you do f of g, state the domain and range, or just domain, g of f, state the domain.